Welcome all. Today we are going to learn about the electromagnetic engineering. In there we are going to learn about the transmission line. Here there is a question on transmission line. Let's go through the question and see what can we do for that question. In transmission line, we use an equation for input impedance. That is, input impedance is equal to Z0 into ZL plus JZ0 tan KD over Z0 plus JZL tan KD. In this question, it tells that the open circuit and the short circuit impedance measured at the input terminals of a lossless transmission line of length 1.5 meter, it's about quarter length, are minus J54.6 ohms and J103 ohms respectively. What they are asking first is define the characteristic impedance is Z0 and phase constant K. For that question, we only need this Z in input impedance equation to solve that question 1. Here the Z0 tells about the characteristic impedance while ZL tells you the load impedance. Here K is a phase constant while D is distance. So in our question it tells that the open circuit impedance is minus J54.6 ohms and the short circuit impedance is J103 ohms. So let's put that information into this equation. Here open circuit impedance is minus J54.6 ohms and short circuit impedance is J103 ohms. These are the information we are getting from the equation. So let's put this short circuit and the open circuit impedance marked to this equation. So in that way, in open circuit impedance, the ZL, the load impedance, is going to be infinity. It goes to infinity in the open circuit, and in short circuit the ZL is considered to be taken the value of 0. So let's put this ZOZ, ZSC to this equation and see how the equation is transformed. So ZOZ, here ZOZ is equal to Z0. ZL is taken away from these expressions, two expressions, like ZL 1 plus J Z0 over ZL tan KD, and likewise in here also the ZL is taken away. So Z0 over ZL plus J tan KD. As the value it goes to infinity, the ZL and ZL is cut away from the limits. Then the equation tends to be, here the value is going to be infinity, therefore the value of here is going to be 0, and here the value is also going to be the 0. So these two are taken, these two are cut away. So the rest remaining is Z0 over, here this one is taken away, so only one remains, Z0 over J tan KD. Here the open circuit impedance. Let's go to the short circuit impedance. Here the ZL is being 0. So the short circuit impedance is equal to Z0, ZL is 0. ZL is 0. Therefore, into J Z0 tan KD over, here ZL is 0, here ZL is 0. So this term is going to be 0. So over Z0. Z0 into Z0. Z0 is cut away from the Z0. Therefore, short circuit impedance is equal to J Z0 tan KD. So these two are very important to this question. They are asking about the Z0. So we need to multiply these two equations and make the Z0 subject, and then we can get the value of Z0. So by multiplying this term, this equation with this equation, we get ZOZ into ZSZ is equal to, here J tan KD, here J tan KD. They are cut away. Therefore, only remains is Z0 squared. So, by making this subject, Z0 is equal to root ZOZ into ZSC. So, substituting the value of here the information, we can get the value of the Z0. Thereafter, we need to get about the value of the K. The value of K can be taken by dividing this equation from this equation. So let's write as ZSC over ZOC. Here the Z0 is being cancelled out. Therefore the remain is J tan KD, all the thing squared. So the J squared is taken as -1. So that -1 value is taken to here, and here minus ZSZ over ZOC is equal to tan squared KD. So tan KD is equal to root minus ZSC over ZOC. We need to make the K subject. Therefore, K is equal to, let's go to the next page. Therefore, tan KD is equal to root minus ZSC over ZOC. So, K is equal to 1 over D tan inverse root minus ZSC over ZOC. Here the question, it says 1.5 meter. That is the length of the transmission line, that is the value of D. So substituting that value D to here 1.5 and the values the ZSC and the ZOC, the J54.6 and J103. So these, by substituting this value to this equation, we can get the value of the K, the constant K, the phase constant. So here we get the answer for the question 1. Let's go to the second question. Second question is the without changing the operating frequency, find the input impedance of the short circuited line that is twice the given length. Short circuit impedance equation is this: ZSC is equal to JZ0 tan KD. Now we got the answer for the Z0 K and D is given as 1.5 meter. In that question, in question 2 says that D is twice, then the value of this D is not 1.5 meters, it's 3 meters. So substituting the value 3, the K value taken by the previous question and the Z from the previous question, we can get the new short circuit impedance value. So this is the way how to do the second question. Now let's go to the third question. How long the short circuited line be in order for it to be appear as an open circuit at the input terminals? The third question, if it wanted that transmission line in order to appear as an open circuit. So to be appeared as an open circuit, the ZL value must be go to the infinity. So ZL, so in both cases there is Z0 or Z and ZSC, there's a value, there's a term as tan. That tan value must be go to the infinity. Therefore tan KD must be go to the infinity. Therefore KD is equal to 5/2 plus n5. This is the solution for the tan KD is equal to infinity. So we only need the distance. Therefore D is equal to 5/2k plus n5/k. So the answer for the third question is this. So now we complete the question 1.